The internet is not a cloud. It's not floating in space. It's not magic. And it's definitely not wireless. It's warehouses the size of football fields, filled with machines that never sleep, consuming as much electricity as entire cities just so you can load a YouTube video in under a second. This is the insane engineering of data centers. So, what is a data center really? The simple answer is, it's a giant building full of computers that store and process information for the internet. But technically, it's a complex ecosystem of server racks, networking equipment, storage arrays, massive power distribution systems, and industrial-scale cooling infrastructure. Every single time you stream a video, send a message, or load a website, you're interacting with thousands of physical machines located somewhere in the world. There is no cloud, there are just buildings. Let's start with the servers. The brains of the internet. Think of them as incredibly powerful computers, stacked tightly together in racks. A single rack can hold anywhere from 20 to 50 servers. Each one of those servers has multiple CPUs, hundreds of gigabytes of RAM, and blazing fast SSD arrays. Now, multiply that by thousands of racks, spread across hundreds of these facilities worldwide. You're looking at millions of processors working simultaneously, and they run 24/7, no breaks, ever. But here's where the real engineering challenge kicks in: power. Data centers use insane amounts of electricity. A single large data center can consume between 20 to 100 megawatts. That's enough to power tens of thousands of homes. This power comes in from high-voltage utility lines, gets processed through on-site substations and transformers, and then flows through complex switchgear and power distribution units, all the way down to the individual servers. But the truly insane part, they cannot lose power, not even for a millisecond. So, they have massive uninterruptible power supply battery banks that kick in instantly. For longer outages, they have rows of giant diesel generators ready to fire up. Many even have redundant power feeds from completely separate electrical grids. This is a concept called N+1 or 2N redundancy. Everything has a backup, and then there's a backup for the backup. It's a system designed for absolute, uninterrupted uptime. All that electricity creates a huge problem: heat. Computers get hot. Very, very hot. In fact, servers convert nearly all the electrical energy they consume directly into heat. A single, dense rack can generate 10 to 30 kilowatts of heat. That is like running a dozen household ovens in a phone booth. Multiply that by thousands of racks, and you have a furnace to fight this hidden war. Data centers use clever designs like hot aisle and cold aisle containment, raised floors to distribute chilled air, and massive industrial-scale HVAC systems with chilled water loops. Some even go to extremes, using direct liquid cooling, immersing servers in non-conductive fluid, or even using cold ocean water to keep things from melting down. Without this constant cooling, the entire facility would overheat and shut down in minutes. So we have power and cooling, but how does the data actually move? That's where networking, the real backbone, comes in. Inside the data center, servers connect to top-of-rack switches. That traffic gets funneled up to aggregation switches, and then to core routers that connect the entire building to the global internet backbone. This is all done with fiber optic cables, which transmit data as pulses of light. We're talking speeds of 100 gigabits per second. For 100 gigabits per second, and even terabit speed links between data centers. These fiber optic cables run in protected routes underground and in massive submarine cables that stretch across entire oceans. The internet is literally beams of light traveling through glass at unimaginable speeds. Now, with all this hardware running non-stop, things are bound to break. Hard drives fail constantly. Servers crash, switches die. Data centers are built with this assumption. They use incredibly sophisticated systems for redundancy and fault tolerance. Distributed storage systems spread your data across multiple drives and machines, so if one fails, your data is safe. Replicated databases and failover clusters mean that if a server goes down, Another one takes its place instantly. Load balancers distribute traffic so no single machine gets overwhelmed. If one component dies, your request is simply rerouted in a fraction of a second. You don't even notice. The entire system is built assuming constant failure, and the buildings themselves? They're engineered like modern fortresses. Data centers are constructed with seismic reinforcement to withstand earthquakes, and blast-resistant structures for fire suppression. They don't use water, which would destroy the electronics. Instead, they use inert gas systems that suck the oxygen out of a room to kill a fire. Security is extreme, with multi-layer physical access controls, biometric scanners, and constant surveillance. Their location is also part of the engineering. Some are built in remote deserts, deep underground in former military bunkers, or even in Arctic regions to take advantage of the natural cold for cooling. So let's talk about the sheer scale and impact. Data centers now consume over 1 to 2% of all global electricity, and that number is rising fast, driven by AI training, cloud computing, and our insatiable demand for streaming content. Entire power plants are being built just to supply these massive server farms. The internet isn't light and fluffy, it's heavy, electrically heavy. When you put it all together, data centers are the most invisible yet critical pieces of infrastructure on Earth. They are a symphony of electrical engineering, mechanical engineering, computer science, networking, and structural design, all running in perfect harmony at a planetary scale. And every single time you refresh a page, thousands of machines spin up in a fortress somewhere in the world, just for you. It's an engineering marvel that makes our digital lives possible. Thanks for watching.